So hey guys, this is Biswajit and welcome to my YouTube channel. First of all, I'm going to talk about the pipelines, the transformers, the machine learning part. And if you have not watched the previous video, just go and watch the previous video where I explained the data downloading, processing part. So that was a light processing that I have done. So now we are going to get into heavy data processing techniques. So I left the video over here where I showed you how the data looks like at this phase. It is going to be interactive if I show you the data in every stage. What we need to do is I have the data over here. Now we need to divide the data into train, test, split. Okay, we should be having a training data and the test data. So here I am using the Sklearn. There is something known as train, test, split. It is going to divide the data for you into training data, X train, X test, Y train, Y test. So okay, so this two we are going to use for the training part, the X train and the Y train, and X test and Y test for the testing part. I know the like the data provider have already provided the test thing, okay, but we are going to divide the training data into this, and we are going to test, like final testing, we are going to do use this data. We should like reserve some test data for our testing, and this is the test data that I have taken into consideration. This is the data. This is how I am able to split the data. Okay, trend test split. I'm providing the data and the test size. Okay, and this is the random state. The test size .20 means there is a 80% 20% split that I am doing. So 80% will be given to the X train and 20% will be given to the X test, and respectively with the Y train and Y test. And random state is used to just shuffle the data frame. So if you have seen my data previously, so the data looks like this: lesser than 50, lesser than equal to 50, lesser than equal to 50. So we don't want the algorithm to see data in a proper sequence. We want the data to be randomized so that the machine learning is able to learn properly and we can rely on the algorithm. And now where were we? So here that we splitted the data into their particular like training and testing. Now I just wanted to see how my X train looks like. So X train dot head, and you can see this is the X train data, and you can see this got shuffled properly. This is the data of this particular index number 33,000. This is the 23,000 index number. This is 7858 index number. So it got shuffled. Now here I'm also checking how my target looks like. This is my target. This is a classification problem, so we have to deal with this target also. Okay, and this is where our data pre-processing works. Okay, so generally I like to use pipelines because they make our work extremely easy. So I hope I have like I was able to explain standard scalar in my previous videos, standard scalar, one-hot encoding. If not, I'm going to explain them in this video also. So standard scalar is like, for example, you have different data over here. You can see education number is there, 10 is there, 9 is there, 10 is there, 13 is there, and if you look away you can see age is there. So the scales are different: 45, 10, 52, 9. You can see the scale is different. Here if we are able to see capital gain, capital loss, the scale is different, right? So for example, area versus kilometer. So area is a different scale, different metric, and kilometer different metric. Likewise, age is something different. Okay, it has a different scale, and education number, it has a different scale. So scale is different. So we have to make the scales to the same level. So standard scalar is used for that purpose, to scale the data properly. So we can use min max scalar also, but I like to go with standard scalar. Next, what we have is something called as full pipeline. So here we have two different uh, types of data that is present. That is the numerical data and the categorical data. We don't have to handle null values because there are no null values. We are supposed to handle the categorical values and the numerical values. So here what I have done, I have used number pipeline. This is used to handle the numerical pipeline. Okay. And this is the full pipeline that I have used. What this does is this line, it calls the numerical pipeline. This particular line calls the numerical pipeline. And this particular line handles the categorical column, right? I could have made a different pipeline for numerical pipeline and categorical pipeline, different defined pipeline, but I thought that we don't have to handle missing values, so why not this? So I have created a pipeline for to handle the numbers, and in the full pipeline I am just calling my numerical pipeline, and also I'm handling the categorical values, right? And this is the level encoder. For example, you can see this is my target. So my target has the string value lesser than 50k, greater than 50k. This is nothing but string value, right? Lesser than 50k string value. So we need to handle string values because machines can't understand string value. So we have to handle the string value. So to handle the string value, I have used level encoder. This is for the target. So we need to handle this. For that, the target encoder, and these are for our columns. Now what I am doing prepare data full pipeline dot fit and transform xtrain. So I'm passing my xtrain data into this pipeline. It passes, this data is passed to the number pipeline. Okay, this data comes to here, the full pipeline. Then the number pipeline, the numbers get changed. Then it comes to the categorical values. The categorical values get into one hot encoded, right? And all of this data is saved into a prepared data. So full pipeline dot fit and transform xtrain, it changes our main data, and this transformer gets fitted, and this transformers is used for our deployment. So I have made these videos regarding this. So if you have not watched, or if you are not able to understand, just go and watch my YouTube videos. If you follow my playlist, you will be able to understand, because I'll be putting everything in my playlist in proper sequence. So this is how the data looks like. So you can see this is one data of mine. Okay. So the data got scaled. These are my data for the numerical columns. These are my numerical columns, and this remaining are my categorical columns. They got one hot encoded, and I'm printing the first 5 data. So first 5 rows, I should say. So this is the first row, this is the second row, and third row, fourth row, fifth row. Okay, simple. And likewise, I have changed my columns, and also I have to change my target. So I did target encoder dot fit and transform y train, and it changed my target also. For one class it gave me 0, for another class it gave me 1. Because there are two classes, we can simply use level encoder. We can also go for one-hot encoding, that doesn't matter anyways. Because we have two classes, we can just use level encoding. We can also go for one-hot encoding. Now we are going to talk about the machine learning part. So I have used XGBoost specifically because I was learning XGBoost. So I thought, why not use XGBoost and create this more and create this and solve this particular problem. So I have used XGBoost. So in XGBoost we have classifier, we have the regressor. So I am using the XGBoost classifier. So here you can see this is the model that I have created, and it is using eval metric is log loss. It is used for classification. and use level encoding is false. Generally, these things I have done just to prevent warning. There was some kind of warning that I was getting, and to avoid those warnings, I am using this use level encoder false, because already it is level encoded. So it was giving me some kind of warning, and I just resolved it. Tree method is GPU hist. This is going to, if you have a NVIDIA GPU, if you have a supported GPU, most probably NVIDIA is supported. I don't know about AMD. So if you have a supported GPU, what it is going to do, it is going to run the algorithm on your GPU. So you can have a faster computation speed. So this is the model that we are like that is defined over here. I hope I have executed this. Yep. So this is the model. Now, generally, through my experience on machine learning, I don't go away training this model directly. I just go with cross validation score and I just see how my model is performing. Okay. See, I have not executed this. So let me execute this from first. So 32, 15, 36. Let me execute the models. Okay. So if I run this is going to use my GPU, because I have checked that in my task manager, it uses my GPU memory. Yep. And we can see we are getting an accuracy of around 86%, 86%, 85, 87, 86. So our model is sort of a, like, it's a okayish model. Now this cross validation I have done on my training data, right? Prepare data and prepare target, which we already did over here. Prepare data and prepare target on my training data, and it is giving it is giving an accuracy of 86% on this two particular data. Now, if you remember, we have also something known as X test data and Y test data. So let's run the algorithm on this set of data. So first of all, the data is already present, that is X test is already present and Y test is already present. So here what we do, we pass the data into the pipeline, and here we don't do dot fit and transform. Here we do only transform, because we are not supposed to fit on the test data. So we are doing transform X test and transform Y test. If I execute this, and if I show you how this data looks like, for example, prepare test data, it looks like this. It's a sparse matrix, so I will show you in this format. So you are able to understand, right? This is one row, this is another row, this is another row. If I pick up the first row, this is the first row. If I do this, this is my first row. You can see there is a 3 dot. That means there are a lot of data that gets hidden. Since this length is too much, like length is too much, so it is giving that this 3 dots, because it is not able to display everything. So if I do prepare test dot to array, it is able to give me this. This is my test data. Okay. Now if I do prepare test target, you can see this is the data that we have. Since 3 dots means it is hiding some of the data. It is not able to display everything, because obviously it can't. There are so many data items. Now what I have done is let me delete this. I have done the same thing, cross validation score on this particular data. So let's perform the cross validation score on my test data. So you can see 83%, 85%, 85%, 82%, 85%. This is going to give you a less percent less accuracy, because there is no data, like there is not much data that is present for the algorithm to learn, because the algorithm needs lots and lots of data. So I have just used this to test whether my algorithm is working fine or not. Even I use this to test. So these are the two tests that I do from my end. So now I am training the model. Now it's the time to train the model. Okay. uh, I saw how my model performed. Now before moving on, I generally train my model now, and then I'm going to tell you the reason, because I have to know how my model is performing with by calculating the precision, recall, and the confusion matrix. For that purpose, I have to train the model. I'm training the model on my prepared data and the prepared target. That is nothing but my training data and my training target. So I am doing just XGBoost classifier.fit, and it's going to take some time. Okay, it was very fast, and the model got prepared. Now I am doing XGBoost classifier.predict prepare test data. I'm predicting on my test data, and I'm getting this prediction 110111. Okay, I know you're not able to understand this part because you can't understand 1010. I'm going to explain everything bit by bit. So now the reason I I trained this model is because I wanted to see the F1 score, the precision score, the recall. Now what I can do, I have the prediction. Ypred is over here. This is my prediction on my test data. Now classification report, if I print the classification report on this data, you can see I'm getting an F1 score of 87%. I'm getting a precision of 90 and recall of 84. It's not bad actually. Precision and recall should be as close to each other as possible. So like if the precision was 85, then that is actually good. And even 1984 is actually also very good. So precision and recall, as I have studied, it should be close to each other. It should be high, the value should not be low, it should be high, and the value should be close to each other. Generally, if precision increases, then the recall decreases, and if recall increases, then precision decreases. So this is something that happens, and that's why precision and recall should be like it should be high, and it should not vary with each other. Like it should be like as close as possible. So here 90 and 84, I think it is good precision and recall score, and I'm getting a okayish F1 score. 87% is almost close to 90%. So now if I print the confusion matrix on my prepared test data and my Y prediction, you can see I have 4124. These two are my positives. Okay. And these are my negatives. So you can see these are my true values, like 4124 and 4283. These are my true values, and these are my false values. Like the algorithm, the algorithm was able to identify this values as correctly and this values as correct values. And for this it made mistake. For this it made mistake. So this is the confusion matrix, and then what I am supposed to do? As I said previously, this 1010, this does not make much sense to you. This is nothing but our prediction. The data we gave, the model got trained, and we said the model, please predict for this values. So it predicted 0101. So it doesn't make much sense. What is this 0101? For that, we have to do something known as inverse transform. I am doing inverse transform on my Ypred, and it gave me this particular value, greater than 50k, greater than 50k, lesser than or equal to 50k. This is what we want. The prediction, the actual value, the actual data that needs to be predicted. This is what we are interested in. This is the prediction. So this is the prediction for our test data. Okay, our own test that we divided. So this is the metrics. Okay, classification report. This is the confusion matrix, and this is the inverse transform. This is the actual data. Now we are already getting an accuracy of 87%, but is it possible to increase the accuracy of this model, like from 87 to 90 or 91%, 92%? Is it possible? And the answer is yes, it is possible. You can get more out of your model. For that, you have to do something known as hyperparameter tuning. So hyperparameter tuning is an extremely powerful and extremely useful technique. I should say it's a tool that is given so that you can squeeze more out of your model. That is the reason I trained my model before. This is where I trained my model before, okay, and I checked for metrics. Now I'm going to do hyperparameter tuning, like I'm going to make my model better. And how can I tell my model is better from my previous model? By using this. We already have the details of our old model. This is the classification report of our old model. Now we can do hyperparameter tuning. We can modify. We can bring we can make our model much better, and then we can check. We can compare this metrics with the new metrics that we found out. We can compare the confusion matrix also. So this is how we can go ahead. So this is the use for hyperparameter tuning. So first of all, you have to prepare a dictionary. This is the dictionary that is used to generate the parameters. So now I'm going to explain this part. So in XGBoost, you can see there are many parameters that is present. So these are nothing but called as hyperparameters. So there are many hyperparameters that we can control, but how we are going to know that how many hyperparameters are there, or which hyperparameters I'm supposed to toggle with? To get the list of all the hyperparameters, you have to come to the XGBoost model. Yeah, here is a model. Just do shift and tab, and it is going to give you all the hyperparameters that is present. All of it is present. Since I am in the learning phase, I also don't know what all of them does, but the documentation is already provided. You can go ahead and read. I toggle few of them which I am able to understand. For example, I toggle with learning rate, max depth, level encoder, n estimators, then boosters, n jobs, gamma, minimum child weight, maximum delta, which I am able to understand. So I just copy those hyperparameters and I just paste them in the form of a dictionary. So you can see n jobs as -1, so it is going to use multi-threading. Evaluation metric is log loss, which I have showed you before. N estimators is that it is nothing but the number of trees that is going to create. So I have given 1,3, that means 1 and 2. Means this gives a value. Range is nothing but it is a generator which gives this value 1 and 2 for this particular range function. So these are the values that I have given from my end: learning rate, verbosity, booster. This is nothing but the type of trees that we are supposed to use and the algorithm for that particular tree. This is the GPU ID, GPU history to use our GPU. This is the number of parallel trees, gamma rate, minimum child weight. You can see. So these are the parameters that I have passed from my end to make my model better. So what the grid search is going to do, it is going to do combination of all the parameters that I have passed, and it is going to pick n jobs -1, log loss. Here from range it will take one value. From learning rate it will take 0.01. From verbosity it will take 3. Like this, it is going to find out for which set of hyperparameters I am getting a good model. The model accuracy is high. So it is going to find out all the models, all the parameters in this fashion. I'm going to make a detailed video on hyperparameter tuning, but this is the functionality of, this is the basic idea of what hyperparameter tuning is. So you have a model, okay, you want to make that model better, you want to squeeze more out of your model. For that purpose, hyperparameter tuning is used. Here you pass all the set of parameters that you think might help your model. So the model learns using these hyperparameters. It trains using these hyperparameters, and the best hyperparameters is selected with them with that particular model. So this is the grid search algorithm. Here you have to define the grid search object. Okay, this is the object and this is the classifier that we are using. That is nothing but the XGBoost classifier. And we have to define the parameter grid. This is the parameter grid. So we have to tell the parameter grid. We have to pass this over here. And cross validation, we are taking 10 cross validation. This actually happens on a cross validation set. So we are using 10 cross validation set. And in jobs as -1, we are using multi-threading, verbose as 3. And I'm not going to execute this because it is going to take a lot of time, and my video will get crashed, my recording will get crashed, recording software, which I don't want. So here you can see fitting 10 folds means 10 cross validation for each of the 1600 candidates. 1600 candidates means these are nothing but the total number of combinations that it found out through this parameter list. So there are 1600 number of combinations we can get from this parameters. So for example, let me give you an idea. For example, in the first case, n jobs will be -1. In the second case, first case n jobs is -1, then log loss, then n estimators as 1, then learning rate will be 0.01, verbosity will be 3 because it has only one value, then GB tree, then 0, then GPU hist, then 1, then gamma as 0 point, 0, then minimum child weight as 1, then this is false. This is the set 1 of parameter. And in set 2, it is going to pick something like everything is going to be same, or I should explain this also. It should be -1 because n jobs is one value, and it is going to be log loss. Here it will change because we have given range 1,3. Here it will change. It will keep this as 2, and rest everything will be same. Now this is done. In set 3, this will be same. This will be same because they have only one value. It will keep range as 1, and it will change the learning rate. Now it will become 0.1, and rest will be same. And now the same thing for set 4. Everything will be same, like this will be same, this will be same, and it is going to this will change. This will become 2, 0.1. The rest will be same. So getting the idea. So it is going to take this many combinations of data, and it is going to compute the model. So likewise, it went to set 1600, right? So it went to set 1600. So that many number of combinations of parameters it was able to find out. And now it is going to train our XGBoost model with set 1 parameters and compute the accuracy. Then XGBoost with set 2 parameter and find out the accuracy, right? So like this, it is going to go for XGBoost set 1600 and find the accuracy. And the best of all of these models will be selected. Okay, the best of them will be selected, and we are using cross validation also. So there is little bit extra that is being done. So I won't go much into depth in this because otherwise you are simply going to get confused. So there it is also using cross validation set. So for 10 folds, 10 into 1600 will be 16,000. So total 16,000 fits it is supposed to do. So actually this is done for one cross validation set. And for second cross validation set, it is going to do the same thing. For third cross validation set is going to do the same thing. So I don't want to go into much detail, okay, because there is some more that is going on. But remember, this is something that is happening internally. I don't want to remove this, let it be there. So this is how grid search works. There is another technique known as randomized search. That is something different. And grid search is something extremely easy to understand. So you can see these are the number of combinations it made. There were more. Okay. And this is the model. This is the particular model. Okay, we have more data. This is the particular, this is the best model that it found out. This is the best model that it found out. So how we can get this? We can do grid search dot best estimator. It is going to give us this model. This is the best model that it found out. Now, and the best set of parameters is given by grid search dot best parameters. So this is the best parameters, right? Before moving on, okay, let me tell this also. So what is the best score? You can see 0.82, 82% accurate. Now you might tell me that we were receiving something around 86%, and our improved model gave us an accuracy of 82%. Why is it like this? So the reason why it is 82%, why it is not higher than 86, is because of this. If you check properly, you can see there are only two values in estimators. In learning rate, there are only two values. In booster, there are only two techniques. So here also number of parallelity is only two values, right? Here there are only few values, only two values. This is, I have done this so that I am able to run this faster. But generally there are more, like for example, it is having 10 here, it will have more, like 1 here, it will have 0.001. So now if I use this, all of it, then our model will be more accurate. Here I have not given high value so that my learning is faster, so that I get output in a quick time. If I give more values, if I increase the range, if I increase the size of this list, so there will be more number of combinations. Here will be more number of combination, and it is going to take a lot of time. Like I was in a situation where it took me 1 hour to do grid search on XGBoost. So I don't want to waste that much amount of time simply because I won't be able to work because my machine will be occupied. So I just restricted the value in a small search space. This I have put this value in a small search space. Like there are only two values over here, If you want, you can obviously go and increase it. Only it is going to take some more amount of time for it to execute. So if I do this continuously, then our model is going to get better. Definitely it is going to be more than 86%. Now if I move ahead, I hope I was able to explain you. Now again we are checking the metrics. So we are fitting, this is the best model, right? This is our model. I'm assigning that model to a different variable, and I'm calling that variable as my best model. You have to fit the model, right? The model is not fitted, you have to fit the model. Okay, this is something you have to keep in mind. You have to fit the model. I'm fitting the model without training data again, and I'm making the prediction on my test data, so on YPRED, and And again, I'm printing the classification report. You can see it is giving me a low F1 score. The reason, as I said you before, I have only given few parameters in grid search. So that's why it is not able to perform better, because it does not have a large large parameter space. I am given it a very small parameter space. That's why the F1 score is smaller. If you increase the number of parameters over here, then you will get good accuracy. It might also cross 90% in some cases. And if I move ahead, you can see 81% is accuracy, precision is 87, recall is 76. Sort of a low precision and recall, but still it's okayish. But F1 score is less, so accuracy is less. So we have to increase this accuracy by increasing the parameter space. I am going to make a video on grid search and hyperparameter tuning so that you are able to understand those things. Now I'm doing the same thing, classification report, as I said, and the same thing with the confusion matrix. You can see there are many false values, and we have good amount of true values, but there are also false values. You can see 1173. So there are a high number of false values because our model is not good. So I'm going to cut the video at this stage, and there is some few things that I am supposed to do, and I'm going to show those things in my next video. So if you are able to understand, just give a like, and thanks for watching. If you have any kind of doubts, do comment in the comment section below, and we'll see you in the next video.